Okay, hello class, welcome back. Today we're going to be talking about our sky. This is what a lot of people think of when they think about astronomy, right? We're here on Earth and we look up and space is out there. Of course, the way to really think about it is, we're in space. We're floating around in space just like we see these objects in space. Well, we're just one of those objects, right? It's just, we're a dot. When our spacecraft go to other planets, they look back at Earth. Earth's a dot, right? Well, we see these stars. We know there's all these planets and bodies out there. We're one of them, right? But today we're gonna talk about when we're looking out into our sky. So let's do that. Let's go over here, and we're gonna look at this diagram here. Okay, so this is a really useful model to use when looking at the sky. We're all used to maps, Google Maps. All of you know how to do it. It's on your phone. You can find things. Well, if you're looking at the sky, when you're looking at Google Maps, you're looking down at the Earth. When you're looking at the sky, you're looking out. Well, you have to have references. Just like Google Map has north, south, east, and west. There's directions and that sort of thing. Well, the sky has similar features. Google Maps, right? We divide. We live in regions. We live in California. California's in the United States. United States is in North America, right? So we named all these places on our planet Earth so we can get around. The sky is much the same way, right? So we have to get our bearings. So this is a really useful diagram. It's called a celestial sphere. Okay, that term is gonna be on the test. I'm telling you right now. So celestial, right? So celestial, and then sphere, because it's like a ball, right? So a sphere. So as you can see, in the center of this is Earth. Now we're used to being on Earth and looking out. So this is kind of what we're going to do this time is we're going to pretend that we're out here. We're Martians or something, and we're looking at Earth. It's useful to think of it this way. So we know that Earth has a North Pole, for instance, right? Well, if you take the North Pole and you extend it out into space, it's now called the North Celestial Pole. And all this is in your book, right? You're going to see all this in your book again. So it's called the North Celestial Pole. Guess what? Test question. So if you take Earth's North Pole and extend it all the way out into space, it's called the North Celestial Pole. There's a star up here. If you were to go to the North Pole and look straight up, there's a star up there. It's called Polaris, or it's also called the North Star. We're going to talk more about Polaris and the North Star in a bit, right? So if you go north. Now we live in California right now. So if you're in California, we can see the North Star, but we don't look straight up. We have to look at an angle. The angle is about 38 degrees over the horizon. So if you look at the ground and you look up 38 degrees, that's where the North Star is. Because if you live at the North Pole, it's straight up. We're in California, so we're up 38 degrees from the equator, California. So to see the North Star, that's right. I'm introducing you to this, so don't worry too much about that right now. Well, on the other side of the Earth, so there's the North Celestial Pole, is the South Celestial Pole. So we know that there's a South Pole on Earth, right? We know that South Pole. That's where penguins live and things. And how about polar bears? No, polar bears are only in the north, right? Are there penguins in the north? No, penguins are only in the south, right? So you go to the South Pole, there's penguins, and it's the North Celestial or the South Celestial Pole. Okay. Then if you take Earth's equator, we know that the center of our planet, right? The center of the Earth, we have the equator. Countries like Ecuador are at the equator, right? So if you extend the equator out into space, it's called the celestial equator. I want you to know that term. So it's kind of easy because you already know what the equator is. You just throw the word celestial in front of it. And it's good. It's the same word we threw in front of for North Pole, North Celestial Pole, right? So that's good. You're not learning too much more. Just we're using the word celestial. And you already know what celestial means. It means space, right? So celestial. Okay? So now we're kind of getting our bearings in space. So kind of the way we divide up, you know, when we're looking up, right? So we know where the north celestial pole is. And then from there we can find other objects in space, in the sky, when we look at the sky. Same with the south, right? If you live in Australia, you care where that is. We're going to learn in just a bit how to find a north celestial pole from here in California, right? So I want you to know the celestial equator. You have to know that term. That's easy. Now here's another term you may not have heard before. It's called the ecliptic. The ecliptic. Well, you all know if you go and you go and you find a globe in the store, the globes are always tilted, right? You're like, what? Why aren't they straight up and down? They're always tilted. That's because Earth, you know, we know that Earth orbits the sun. Everybody knows that, right? So that takes 1 year for Earth to orbit the sun, right? So if you're 60 years old, you've done, you know, 60 orbits. If you're 20 years old, you were born. And we use orbits around the star, our star. So when you say you're 20 years old, well, it really means that you were born and then we've gone around the star 20 times, right? So we use that for time. It's convenient, right? So that's what it really means. Okay. But what happens is we go around the sun. So Earth orbits around the sun, but the North Pole isn't straight up. It's tilted a bit, right? It's tilted a bit, and that gives us another feature called the ecliptic. We're going to learn more about the ecliptic later. When you're on Earth looking out, because of the tilt, and this can be a little bit difficult to conceptualize, it's the path of the sun in the sky. Interesting. So it's the path that the sun takes in the sky. Now, something you may not have known, the planets, you know, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, they also follow the ecliptic. So the sun, the planets, and the moon, they all go in the sky on the ecliptic. So you're going to see that in one of the other films, one of the other videos that we're watching. Okay, so these are terms you have to know. North celestial pole, south celestial pole, celestial equator, right? These are pretty easy. North pole, south pole, equator, right? A new word maybe, ecliptic. The ecliptic, it's tilted from the equator. That's because Earth is tilted in space relative to its orbit around the sun. Okay, and don't worry if you're not getting this right away. There's going to be other videos you're going to watch, and also the book has good diagrams, and we're going to talk about this more. Okay, so this whole model is called the celestial sphere. That's the model that we use to help us find objects in the sky. We know where the sun is during certain times of day. We know where the moon is certain times of the month. We know where the stars are certain times of the year. Okay, so it's a model that we use. All right, let's move on. Okay, so the North Star, we talked about the North Star, and where the North Star is, remember I said that the North Star is if you take the North Pole and you extend the North Pole up into space, it would point at the North Star. So that's what we're seeing here. Let me zoom in on this little diagram right here. Okay, look at this, folks. Pretty snazzy camera operator. Okay, so to find a North Star. So I said that the North Star, because if you were on the North Pole and you look straight up, that's where the North Star is. But California isn't at the North Pole. So if you have the North Pole, then the equator, California is 38 degrees, right? We know that it's 90 degrees. It would be 90 degrees from the equator, because the Earth is round. It would be 90 degrees from the equator to the North Pole. So Earth is up 38 degrees from there, right? So Polaris, the North Star, if you were to look at the horizon, right, where the ground is, you would go up 38 degrees. How would you find it if you were out in the desert? If you were out in the desert, how would you find the North Star? Well, in California, the Big Dipper, what this is, in old times, they used to, they would get water from a well. Then they had sort of a cup with a long handle. You would put that in the bucket and you would drink the water, right? And everybody would catch colds because they didn't know about hygiene back then, right? So, but now we know, we don't use dippers anymore, but it's called the Big Dipper because back when they used to call it that term, they used this ancient term when people used these dippers, right? Well, if you, so this is very easy to spot in the sky. Once you've seen it, you can always spot it. So I encourage you, if you're camping, if you're out in the desert, and you know, we don't have to go far from where we are in California. Go out into the desert, turn your headlight off, turn your phone off, let your eyes adjust, find the Big Dipper, right? And the way you find the North Star, the two end stars in the cup, they point at it. And the Polaris is about 5 cup lengths up. So if you take how deep the cup is and go 1, 2, 3, 4, 5, that's where Polaris is. So find the Big Dipper, the end of the cup, those stars point at it, okay? This will help you. If you're ever out in the woods and your batteries run out on your phone, you can find where the North Star is. Well, how does that help you? Well, because now that's north. You're standing here on the ground, you found a North Star, straight down is north. But I want to go back to my car, it's in the south. Well, turn around and go south. But I want to go to the east. Well, turn to the right and go east. But I want to go to the west. Turn to the left and go west, right? So yeah, so you now know how to do celestial navigating or navigation. Pretty neat, huh? And then just trivia. There's another, an asterism is a group of stars that look like something, right? It's not an official constellation. It just looks like something. So this looks like a dipper. There's another one called the Little Dipper. The very end star in the handle is Polaris. The Little Dipper though is very faint, so it's hard to see. So we don't use that one. We use the Big Dipper because those stars are very bright in the sky. Okay. That's how you find the Big Dipper. If you're out in the woods or in a desert, you can find the North Star. You now know that is due north. So you go down, that's due north. And now you can, if you know you have to go north, south, east, or west, you know where north is. So you now can do some celestial navigating or navigation. Okay, not too bad. Let me put this back into normal mode. All right, so we'll go like that. That, and we'll continue. Okay, so I talked about the ecliptic. Yeah, this diagram is a little bit tough. Let's use this diagram in our book. So we're going to use this diagram in our book. We said it's the path of. So this is our book, right? It's online, right? It's free online. So this is page 37 in our textbook, right? So this is page 37 in our textbook. If the production quality seems a little hokey, well, it is. Right? If I was in a classroom, I would have all kinds of planetariums and stuff to work with. But we're doing what we can, right? Yeah, it's a shame we have that nice planetarium at LMC, but not now. Okay, so let's talk about, so I told you about the ecliptic. The ecliptic is there because the Earth is tilted and it's different from the equator. If the Earth wasn't tilted, then we wouldn't have an ecliptic, it would just be an equator. But the Earth is tilted. But let's talk about, right, we all know that we have birth signs. So let me study this. Okay, so this is pretty steady. We all know that we have birth signs, right? I was born in July, so I'm a Cancer. You know, you're a Leo, then you're born a certain time of year, you're a Virgo, right? We all pretty much know what our birth sign is, whether we're a Taurus, right? Well, remember, so we all know that Earth orbits the sun. If you're looking from the north, Earth orbits the sun counterclockwise, right? A clock, the hands go from 1, 2, 3, 4. Counterclockwise as if the clock was going backwards. So Earth orbits the sun counterclockwise, right? Well, in June, so say it's June, the month of June, which it was a few months ago, right? If you're on Earth, and then, so we know, like at night we can see the stars. During the day we can't see the stars because the sun overwhelms everything. But we know the stars are still there, okay? So during June, if we're on Earth, and then of course Earth rotates, so we have day and night. So at nighttime, we don't see the sun, but we know the sun is there. It's just we don't see it, right? So the stars that are behind the sun in June. So during the day, if you were to look at the sun, don't look at the sun. If you look at the sun, you know that there's stars behind it. We just can't see them because it's bright, right? So those are the stars of your birth sign, okay? So, and then why does your birth star change? Well, so June, July, August, a couple months later, right? A couple months later, if it's August, and you look at the sun, don't look at the sun, but if you look at the sun, well, those stars back there are Cancer, right? And then you keep going. So August, September, October, November. So as you move here, you know, so the Earth continues its orbit around the sun. It's Leo, right? When you're here, you know that in Earth, so you know the sun is here. The stars that are behind the sun are Virgo. When Earth is here in its orbit, the stars behind the sun are Scorpios, okay? So that's how your birth signs are determined, okay? Remember, today we're doing the sky. So we're interpreting our sky. And then there's constellations all over. We're concerned about the ones, your birth signs are the ones that are near where the sun's orbit is, which is the ecliptic. Remember, that's the path of the sun in the sky. So that's how that works. That's how your birth signs work. Planet Earth orbits the sun. Okay, you're here, look at the sun, right? The stars that would be behind the sun at that time, right? In August, it's Cancer, it changes. So that's how your birth signs work, okay? Not too bad. Let's continue. So let's continue with our tour of the sky. Okay, let me put the camera back here. There's a lot going on here, folks. Moving the camera all over the place, right? Let me move this back a bit. Okay, there we go. That's better. Okay. So let's go on. So we talked about how to find the North Star. Let's continue. Finding the North Star, right? You all know how to do that now. We talked about the ecliptic. Okay, let's talk about something else briefly. So we know that Earth rotates, right? It takes 1 day for Earth to rotate. We all know that, and we've divided that up into 24 hours. So you know, we get sunlight, so when we're facing the sun, it's daytime. Earth spins, right? We all know that Earth spins. It's like a top, but we're floating in space. So it takes 24 hours to go around once, right? I said we had the North Pole. Now what happens is, you can see in this diagram here, it's showing that the North Pole is pointing at Polaris. It points at Polaris these days. It's going to be pointing at Polaris, you know, for many more hundreds of years, but eventually it's not going to be pointing at Polaris anymore. Oh no, that sounds complicated. Don't worry, it's not going to happen for you know, we won't notice anything in our lifetimes. But it does, but they've known about this for a couple thousand years, by the way. I'm always impressed when the ancient people knew things, right? They were able to measure this. So Earth wobbles. So what it means is that the North Pole, currently we're pointed at Polaris, but it has a very slow wobble. It's called precession. It's like when the top is spinning, when it starts to slow down, it starts to wobble. Well, Earth has a wobble, but it's not because of we're slowing down. It's because the sun and the moon tug on Earth with gravity, right? The gravitational field. So it causes, but it's very slow. It takes 26,000 years for Earth to do one wobble. So and it's called precession. This is just something to know, right? Nothing's permanent in space. Everything is moving, right? Everything. We all know this. You know, we're living through kind of weird times right now, right? It's normal. Weird times are actually normal, right? So Earth wobbles. So it takes 26,000 years for Earth to wobble once. So here's a picture of the United States, right? North America. Here's the United States, right? Mexico is right there. Canada's up there, right? So what was happening? What were people doing in the United States, in North America and South America one wobble ago, 26,000 years ago? What were people doing? There were no people in North and South America 26,000 years ago. None, right? They all migrated here from Asia maybe 15,000 years ago. Interesting. Let's talk about two wobbles. So it takes 26,000 years to wobble once. There was no people living in North and South America, but there were people living on the rest of the Earth. So 2 wobbles ago. So 26 times 2, so 52,000 years ago. What were humans doing? What were humans doing? Well, you would have to ask, which humans? What? There's only one kind of human? Nuh-uh. 26,000 years ago, there was about 5 different kinds of humans, right? There was us, we're called Homo sapiens sapiens. There was Neanderthals, there was Homo erectus, there was Denisovans, and one more at least. I forget right now. Right? Those were wild times. You know how there's bears, right? We know there's polar bears, there's black bears, there's grizzly bears, right? There's different kinds of bears. We used to have different kinds of people. That was cool. Now, there's only one that's left, right? That's a shame. I would have loved to have met, right? I have a little bit of Neanderthal in me. Different people. Some people have more Denisovan in them, right? So we actually have genetics from these ancient peoples, right? They find their bones and they analyze the bones, and they can, right, the same way you can do your lineage, right? You can find out your ancestry. Well, they can do this to the Neanderthals and stuff. And so like people from Europe, we have about 3% Neanderthal. People in other parts of the world either have no Neanderthal or they have remnants of these other people, like Denisovans, right? So pretty interesting. All right, let's continue. So the Earth wobbles. It's called precession. Know that, right? Okay, now what we're doing is we're going to talk about the moon a little bit, right? Let's talk about the moon. So look at this up here. It says, the same side of the moon always faces Earth. No such thing as a dark side. Well, there is a dark side of the moon, right? And I'm not just talking about the Pink Floyd album cover, right? So, but there's no permanent dark side of the moon. Let's look at this little diagram here. So let's focus in on this a little bit. Let's focus in on this little diagram. What this shows, so this shows that sunlight is coming this way. So the sun is out here someplace, and the sunlight is shining in. So notice that half of the moon is always lit up. Half the moon is always lit up, right? That's called, so it's the lit side, right? The lit side of the moon. The other half is the dark side. Is the dark side. So half of the moon is lit, half the moon is dark. However, it's not permanent because the Earth does rotate. It takes the moon about 28 days to go. We're looking from the north, right? We're on top. That we're looking at the North Pole up here. So we're looking from the top, and then Earth is orbiting, right? We all know that the moon goes around the Earth. It orbits the Earth, right? It takes about 28 days to go around once, right? But the Earth also rotates, and it rotates exactly to how it orbits, so that the same side is always facing Earth. We have another video you're going to watch that illustrates that, right? That's part of this module, right? But I'm just going to talk about this briefly here. So you can see that the moon is always half lit, half dark, but we see different shapes all the time. Sometimes we call a new moon. That means because the 28-day cycle is starting, we don't see the moon because the part that's lit, it's behind the moon, right? So we don't see it. Then the moon is orbiting. Well, we'll see the moon as a small little crescent. So here you can see that the moon, right? We know that the moon is like a little crescent sometimes in the sky. Sometimes it's a bigger crescent. Sometimes we see a half moon. Sometimes it's like an egg shape, and sometimes it's a full moon, right? That's because we're looking at the moon at different angles. When we're looking at the moon here, we just see a little bit of a crescent. When we're looking at the moon here, we see half the moon. When we're looking at the moon here, it's the full moon because it's getting the full